Okay, let us continue for the required letter B. For x equal to 2, again, the same thing, but we need to change the h. H is equal to 0.15. And therefore, we have the same approximation equation, but now we need to evaluate fx plus h is equal to f. Okay, look at my hand. Fx plus h is equal to f 2.15. Okay, because h is 2 and h is 0.15. So 2.15. So therefore, is equal to 7. Then shift e to the power 0.5 times 2.15. If you press equal sign, you will get 20.510. Okay, take note of that. So we are using still the what? The 5 significant figure. Okay, we already what? Rounded up. Okay, supposed to be 50995, but we rounded up into 5 significant figures. Therefore, that is 0.510. Okay, it is clear. Now, since we already know the value of fx from letter A, so we can what? Proceed with our f prime x, wherein x is equal to 2. Okay, so look at my hand. I am writing it down. Okay, so 20.510 minus 19.028 divided by 0.15. This time we are using 0.15. Okay, that is the difference. Previously on letter A we are using 0.3, but now we are using 0.15. So again, put it on our calculator. So minus 19.028 equals divided by 0.15. So the answer would be how much? How much is the answer? 9.88. 8797. Why? Because we are using 5 significant figures. Okay? We are using 5 significant figures. Okay? We have 5 significant figures in letter A, 5 significant figures in all of our solution here. So let us take a look. Okay? So if anybody doesn't yet know what is 5 significant figures, please look at my hand. I will count. 1, 2, 3, 4, 5. So there are 5 significant figures in my solution. Okay? Okay, is that okay? So now let's go to the next page. So the answer in that page is 9.88. Okay, 9.88 is correct, but that is not 5 significant figures. Okay, that is not 5 significant figures. Take note. But because his answer is 9.8800, okay, he wants to express that he is giving us the 5 significant figure, but that is not correct. The 5 significant figure answer is 9.8797. Okay, we have to round up at the 5th significant figure. Okay, this is correct his answer is correct, 9.88, if we are doing the 3 significant figure. Are we clear right now? Are we clear? Are we clear? So that is the difference. Okay. Note, any question? Any question? So the PowerPoint presented the answer as if he is expressing it as 5 significant figures, but that is not correct, because the correct answer for 5 significant figure is 9.8797. Again, so let us go to the third requirement of the problem, letter C. We would like to solve for the approximate error. So approximate error is previous and present. We need previous and present. So our previous answer and present answer. So let us compute. Our present answer is what? Is 9.8797. So minus our previous answer, 10.263. And therefore, if you use your calculator, let's again use the calculator, because it is possible that the answer would be
negative 0.3833.
Okay, so let us check. So practice. Don't just follow the example without checking, without verifying. So there are already plenty of errors that we found out. Okay, so 10.263, and then the answer is negative 0.3833. If we do the 5 significant figure, this is the answer. Look at my hand. Okay, we are doing the 5 significant figure. The answer is negative 0.38333. Okay. Okay, look at my hand. I will count it for you so that everybody would be cleared up. 1, 2, 3, 4, 5. Okay. So 5 significant figures. So the answer in the PowerPoint presentation is negative 0.383. And that is also correct, but that is not 5 significant figure. However, take a look. He presented it as if it is 5 significant figure because he added 2 zeros. Okay? Okay? But that is not so fast. Okay? That is not so fast. We already know the correct answer. Okay? Okay, any question with this problem? So let us move on to the next one. Please give me the timestamp. Maybe this one. Oh? Maybe this one. Okay. So this is the next problem at timestamp 28 minutes 14 seconds. So for fx is equal to 7 e to the 0.5x at x is equal to 2, find the relative approximate error using values h is equal to 0.3 and h is equal to 0.15. So we already solved that. So from example 3, the approximate value of that f prime is equal to 10.263. We already know that using h is equal to 0.3 and 9.88 using h is equal to 0.15. So we'll just what? We'll just we already solved this. Okay. We already solved it. This is what? We are all only solving for approximate. Okay. Approximate error is E sub A. Okay. So look at my hand. E sub A, that is approximate error. But we are going to solve for relative. Okay. What do we mean by relative? We would like to use another what? Symbol epsilon sub A. So that is relative. So that would be what? Negative 0.3833 over the present approximation. What is that? 9.8797. Okay, what is the relative approximate error? Use our calculator. So 0.38333 divided by 9.8797 equals what? Negative 0.0388. So 388. Okay. Because if we use 5 significant figure, 38799989. Okay. The answer would be like this. Okay. So 0.038800. Okay, I will count it for you. Look at my hand. Okay. 1, 2, 3, 4, 5. We have 5 significant figures for the relative approximate error. Okay, that is relative approximate error. And this is also usually expressed in percent. If you express in percent, that is negative 3.88. Okay, so since this is now in percent, I will only use what? I will only use 3 significant figures, okay, because this is in percent. Okay, so negative 3.88. So let's take a look at the answer. What is the answer? So the PowerPoint answer is negative 0.038765. Okay. And as a percentage, negative 3.8765. Okay. So you still use what? You still use 5 significant figures in the percent. Okay. If I use a 5 significant figure, I will just add 00. So this will be in percent, negative 3.8800%. That is just 5 significant figures. Okay. So therefore, we know we can correct the what? The PowerPoint presentation. Okay. And if we are asked to get the absolute relative approximate error, we will just use the absolute value. So absolute value symbol. Okay. Absolute value symbol. Look at my hands. Okay. Absolute value symbol. So that is what? It will just become positive because it will become operated on by absolute value mathematics operation. Okay. And the answer of the PowerPoint is 3.8765. Okay, compared to our answer, which is too close. The answers are close to each other, but this is the case. This is the case wherein you can be more accurate than the other engineers. Okay. Okay. So I am actually using this PowerPoint presentation of the author of the textbook. This is not mine. This is from the author of the textbook. When I am studying engineering, I found out that there are so many typo errors in textbooks. Okay. Okay. But how can you find out? You have to do it on your own. You have to verify. You have to be sure. You have to be sure. We have to be sure of our answer. We have to be sure. I am very sure of this answer. So can you pinpoint an error in this handwritten or manual solution? Please pinpoint an error in this typo error or anything, rounding up error or truncation error. You can pinpoint anything from this. Okay. So that is our answer. But anyway, it's very small matter. But for example, our first topical principle explanation of when there is a what? There is a radar example wherein there is a military what? Military equipment that would catch up incoming missiles from the enemy side. So the counter missile of the military did not work properly because of rounding off or because of truncation error that that goes about 100 hours of continuous operations per 10 hours. There is very small 10 hours operation. There is very small negligible error. But when it comes to 100 hours, the error is so great that the radar system of the counter missile equipment did not work properly and resulted into so many fatalities on their side. So that's why it is very important, although we are saying this is small matter. It's small matter. Okay, small matter, but please be reminded of it. It is agreeable that it is a small matter, but when you are okay, what happened? What happened to our my camera is experiencing technical difficulty connecting to Wi-Fi. So let us just continue. So in your monitor, you are looking at how is absolute relative error used as a stopping criterion. So this is the stopping criterion. This formula is the stopping criterion. What is the stopping criterion? I will write it down so that you can take a look at it. Stopping criterion is epsilon s, which is equal to what? 0.5 times 10 raised to the exponent 2 minus m. That is in terms of percent. That is the stopping criterion. What is m? M is the significant digits, the number of significant digits. Okay, m is the significant digit. M is equal to significant digits. Okay, so this is the formula, stopping criterion. So if we say 2 significant digits, then the stopping criterion will stop at that. And since the operation, the mathematical operation will stop, it will tell us at how many digits we will have the 100% sure answer. How many significant digits? Okay, so that is the definition of stopping criterion. So please, I posted it up in my social media page. And what happened to my okay. Okay. So I posted it up in my social media page, and it seems there's nobody who knows about it. Why? There are many people who knows about it, but that is usually in computer science or computer engineering. And most of my friends in social media, or those who encountered my page, are not computer engineers or computer science graduate. So they doesn't know. So this equation, this stopping criteria, is usually used in computer engineering. Okay, so I may enroll in computer engineering later on. No? I would like to be also computer engineer, but I already know many things about computer, but still I would agree that I don't know 100%. So that's why I want to learn. Okay? So that is the same approach that I would like you to have. Your thirst for knowledge, by having in yourself the perspective that you can learn more, you can learn other things. You're not yet 100% learned. So therefore, you still have a thirst for more knowledge. Okay, anyway, we can do this criterion to stop the operation so that the machine will know when to stop. We, human beings, doesn't need to do this. But the machine have to stop. Because if the machine won't stop, it will hang. That is the one of the reason why machines hang. Okay? And if you do unnecessary things after the machine hang, it will be corrupted, and the operating system will be damaged. And the damaged operating system will make your laptop or computer unusable. So after which you have to go to the repair shop and let them repair your computer. They will just reformat reformat and reinstall your operating system. So that is let us go to the next problem. I am looking for the next one. Cannot find. Okay, here is our next problem. So table of values for the same function at x equal to 2 with varying step size h. Okay, we are going to, so this is now very simple matter. Okay, so I will show you. We will still practice. Use your paper, calculator. Okay. I will show you how to do it rapidly, faster. So you already have what? Our cannot see it. You cannot see the camera.